He's already introduced me, so I don't need to say these things here. So networking for audio plugins is a nice, short, not terribly meaningful title. So if I were to have a more meaningful title, but a longer one, I would have said, I'm here to talk about doing hardware accelerated DSP for audio plugins using commodity hardware. That's the number one most important thing, using commodity hardware as opposed to special purpose chips, DSPs, et cetera, and local area networks, and JUCE. JUCE is not strictly necessary for what I'm going to show you, although I can tell you from experience it sure helps. So, why is hardware acceleration important for DSP? Let's let the man.
Can do a synthesizer that sounds perfectly, but brings down your computer easily.
And that's really the point. You always need more CPU power. I'm not the first to say it today that the Moore's Law CPU roller coaster ride is over now. It probably died in about 2015. CPUs are no longer getting faster every year like they used to, and so we also have at the same time another kind of what I'm calling a tidal change in the computer industry, which is that today's personal computers, using that term very, very broadly, are now built to, not as kind of workhorses, but they're built to be shiny and thin and light and portable and blah, 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 99 different kinds of axes of sellability that are not particularly good for our industry. What about commodity hardware? The reason I'm talking about commodity hardware is it has to do with money. But it's not, the issue is not hardware cost, it's software development cost. Programmers are expensive. Good programmers are quite expensive. Good audio programmers are very rare. And those who can also handle exotic DSP architectures or worse FPGAs, anything like that, are going to be super rare. The tooling and the training for exotic silicon architectures are also quite expensive. So all in all, the cost is adding up. But the even bigger problem than the cost is actually the risk. The hardware business is a fire swamp of business risk. You don't really want to be, if you think you want to be in the hardware business, you probably don't. If you're already in it, you have my sympathy. With commodity hardware, for smaller companies, smaller boutique outfits, the risk is being borne by larger companies who can afford it. Flip side of risk is opportunity. For the foreseeable future, the Facebooks and Googles of the world are going to be replacing servers by the rackful because they've been building them out at an insane rate, and it's nice to, you know, those racks are expensive. You want to put the newest hardware in them. So there's going to be a pile of used servers on the market for a long time. CPU power will certainly be available and affordable. It just won't all be in one box anymore. Okay, so I'm going to stop talking about opportunities for the moment, but I'll come back to it in a bit. Now I want to switch and talk about technology. What am I talking about? We're all familiar with the standard DAW and plugin architecture. DAWs and their plugin interface standards have basically created the market that we operate in. It's a market for dynamically linked plugins, each of which contains green code and red code, GUI and DSP, and they're sort of cheek by jowl. What I'm proposing is, oh, sorry, not quite there yet. So multiple instances, I mean, this everybody knows this. Multiple instances run on one computer, but the whole idea is it's one computer. What I'm proposing is an option so that you can imagine that in your GUI of your plugin, you have a checkbox that says run the DSP locally, everything is fine, just the way you do it now, or run it remotely. And what that means is that your DSP module of your code is now acting as a proxy. It's talking to, as it were, a copy of itself running on a server, ideally a headless box. And audio is coming back. Obviously, you need a fast Ethernet connection to do this, but it does work. Oh, and in future, Sol will make this much easier, the programming for this. But we have to get there. We have to get there from what we have now. Obvious advantages of this: in larger studios, you can put all your noisy heavy-duty DSP architecture in another room where you can have loudly blowing fans and whatever. And in your quiet studio rooms, you can share a common cluster. I've also noted here that you may be using different platforms because over on the right-hand side in your server room, DSP is DSP. You don't need to worry about whether it's AU or VST or AX, whatever. Just going to pop in a couple of things here which I have not done yet, but I want you to be thinking about them because I think this leads to what I hope we'll get a little discussion going about of where we take this. In order to do this properly, if you've got, for example, a synthesizer chained through 3 effects, you really want to put that chaining on the server side. So the question is, how do we kind of standardize that process so that people can begin to do that in a sensible way? Other things, it would be nice, for example, to create mixes for performers, low latency mixes on the server side so you don't have a round trip through the network. Okay, so let's go straight to a demo. To keep this snappy, I've just prepared a video, but right after the talk, I'm going to take this computer, I'm going to put it onto that table over there, and we'll have a full live setup so you can try it. You can come by and ask me. I'll be here through the entire coffee break. You can ask me any questions you want if you want to look at the code. It's all on the table. I prepared this video using two laptops, my MacBook running Logic Pro 10 and an Acer laptop running Linux Mint. They're both on the same gigabit Ethernet LAN. Second laptop, I wasn't even logged in. It was just acting, although it's a laptop and it has a screen and so on, I was treating it as though it was a headless server. That's kind of an important point. In the video, we're going to see only the screen of the MacBook. I was trying to do a split screen thing, and that's too much. And we'll hopefully hear its audio output. And there's a MIDI keyboard which is connected to the MacBook. Okay, so that sets the scene. Here's what I was doing. I had Logic Pro 10 running. This program right here, this plugin is something called Vanilla JUCE. It's a teaching example I wrote for beginners into the JUCE environment, learning about how to do synthesis plugins. Below it is another simple JUCE-based plugin, which is there to show you what I'm doing on the connected keyboard. So we'll start a video. So Vanilla JUCE is really simple, and it's deliberately simple and stupid. So my sine oscillators, for example, they just repeatedly call the sine function, which is going to burn up a lot of CPU. So let's see what happens. It's pretty obvious. I'm going to hit my damper pedal, and I'm going to smack that thing. Every key I've got 61 voices times 2 oscillators, and I'm burning up 60 to 70% of one core. I couldn't have very many instances of this before the computer would completely die. Now, your plugins will hopefully do much more interesting things with all that CPU, but the principle is the same. Start again. Oh, right. So now we're going to, here, I'll stop again. So I added a little bit to my, my teaching demo, my Vanilla JUCE. I added an extra tab at the top there that allows me to enter a network address, actually in a port, and then this all-important button to say connect or don't connect. And remember, I had 2 machines side by side, but one of them is acting as a server. So what I'm going to do is I'm going to open a couple of terminal windows on the Mac, looking at what's going on. I'll just stop that there. There's 2 terminal windows. Each of those is an SSH session, across the wire, doing something. The bottom one shows that I have run this program called Vanilla JUCE Net, which is, it's the same code that I took out of my Vanilla JUCE program that does the DSP. I've just wrapped it differently. I used the producer to create it. I compiled it as a Linux build, and I ran it. And I ran it from the command line. You see there that it says I've already connected and disconnected a couple times before I was recording this video to make sure it was working. In the upper window, I'm just running the Unix top command, which gives us an idea about where the CPU is being spent. So let's connect. Same thing. We got a connection. Vanilla JUCE Net is starting to show up in the top. And now hit it hard again. basically, I don't know if you can see that in the top right, but there's basically next to no CPU activity on the Mac now, and I'm burning, it says 40, I'm not sure how good these numbers are, but basically it looks like I'm burning definitely about half a core on the other machine. That's what that's the entirety of what I'm talking about. Then we get into the details, of course, of how do we do it. Now, I know what you're thinking, latency. What about latency? Well, it's not nearly as bad as you think. The latency that I'm working with right now is 1 buffer interval. The other point I made earlier is that if latency is primarily a problem when you're going to do live recording and your performers need a low latency monitor mix, that can be handled in other ways. Another issue is we've been told, no, don't do network I/O. Never do network I/O on a render thread. Well, relax. Doing the I/O is okay. The problem is waiting on it. So what do? Well, we architect our code so it never waits. And it's really a very simple trick. In your render function, or in JUCE, it's process block, you've got some input data. Let's say if your plugin is a synthesizer, you've got at least some MIDI. You may also have dynamic parameter changes. That, if it's an effect plugin, you may have blocks of input audio. You have to take all that information, you have to put that into your DSP. Your DSP is then going to respond with sound, and you have to send those buffers back to your DAW. Obviously, if you do it in that order in a very naive way, you're going to wait, because it takes time to do that computation. So what we do is we do a little trick. Right after we connect, we fling the input data over there. We don't wait for anything. We just trust the fact that eventually it's going to come back. And it's going to come back without any special programming from us. It's going to sit there within the OS network driver's buffers, okay? And we satisfy the DAW by sending a buffer full of silence. That's why we're always 1 buffer behind. Ever thereafter, you just do it naively. Fling, wait and get, send to the DAW. Point being, you never wait, because these receive calls are always satisfied from data that you already have. The only time they wouldn't be satisfied is if your plugin if your DSP on the other side isn't actually running it in real time. It's not going fast enough, in which case I can't help you. This is not a new idea. Apple had this as early as 2004 in Logic Pro 7 with what they call distributed audio processing. But not very many people used it. It was very locked down. And the most important thing of all for, I think, all of us as people who are interested maybe in writing plugins is they didn't open the APIs. Everyone knows Vienna Ensemble Pro. It's an excellent product. I built my own poor man's equivalent called NetVST, which you can find there. All these links, by the way, I'll give you a single URL at the end, which you don't have to frantically write all this down. And these things work very nicely, but they have one major limitation, which is you're running your plugins, everything, GUI and everything, on a remote machine, which means if you don't have that remote machine beside you, if it's sitting in another room, then you can't get at the GUI. You don't have a local GUI. And there's some other things. I promised I'd come back and talk to you about business opportunities. So let's start with opportunities for larger companies. Larger companies, opportunities to offer premium products. If you're Native Instruments and you want to apply this technique, you've got to rework, what, half a dozen plugins? And you can offer Native Instruments Complete Server Edition. Do that. You can do that in a week. If you're Roland, you got a few more to do, but you could do something similar. Even if you're Universal Audio and you already have your own perfectly good custom hardware solution, there's nothing wrong with putting that on a server and making it into a shareable high-end tool for, or high-end product package for larger buyers. If you're Waves, you're doing it already, I learned, and that's great, but those APIs aren't open to you and me, which is a limit. For smaller companies, I would like to be able to even do a DIY option where I can say, I want to run Diva or Repro from Yuhi on another computer. I got lots of computers lying around. They just keep going obsolete, and I never throw them away. I don't know about you, but I never throw that stuff away. I would like to be able to run some of these CPU pig plugins on another CPU that I happen to own. Or if you make keyboards, if you're Korg or Roland or Yamaha, You can give people a really nice way to integrate these keyboards into DAWs, which is, these things are computers inside. Just give them a network jack, and then all the programming is exactly the same. And finally, once your customers are running servers or the equivalent thereof, they've got something that's running 24/7, you've got some nice, nice new opportunities to service them. You can automatically push updates, you automatically push trial versions of new products. You can even experiment with the idea of a metered use pricing. I would really like to be able to get rolling cloud without having to pay a fixed amount for it every month from now until the end of time or until my bank account is drained. I would like to be able to say, no, give me the lot, but charge me for what I use. Then I feel that it's more fair. That's my personal opinion. So I think there's a lot of opportunity. That's just everything that I showed you before, so there's nothing new there. I want you to get the code. That demonstration that I gave, all that code, and there's not a lot to it, is on GitHub. It is very permissively licensed. It's under MIT license. And it's available for you to start playing around. I would like to encourage you to play around with it. Beat it up, see where it fails, see where it's good, and so on. And please do, this is my email address, please do contact me. I'd like to thank you for your attention. I made this talk deliberately very, very fast because I want us to have time to discuss it. I'm here to start a conversation about how do we make this happen, because I really believe in it. I think it's good. And I want to hear from you about that, so it's enough of my yakking. I'd like to, yes. Thank you for your time and attention. I want to take your questions.
Thank you very much, Shane. Are we on? Hello? Yeah. Yeah, thanks, Shane. Any questions for that? That was really interesting. Down there?
Have you thought much about getting data back over to the GUI, for example, like if you had an FFT or anything like that?
Yes, yeah. So that falls into the category of what I call GUI visualizations. So for example, if you wanted to do this type of change to Serum, which has really nice visualizations, you get basically there's two ways to do it. One is you can say it's entirely a GUI function, so we'll do it inside the GUI code, in which case nothing changes. Or if you were doing, let's say, a live waveform visualization or something like an FFT, something like that, that really has to be done as part and parcel of the DSP, it's going to be important that whatever protocol is used across the wire be extensible enough that you can say, okay, I'll compute a vector full of stuff, and I'll send it back to my GUI to drive the visualization.
Okay. Any more? You got one at the back.
Let's go.
Hot mic.
Is there any sort of, you've talked about a bunch of different companies doing stuff. Is there any sort of standard you've got or ideas for that, or how would that look?
That's a great question. One of the things that's very near and dear to my heart is that if we wait for any of the usual suspects to define a standard for us, we will get what we get. And that means it's going to be platform specific, it's going to have aspects that are proprietary, there's going to be licensing concerns and so on. I really think that if we want to make this happen, what I would love to really see happen is that we start right now, we start this conversation and we do the first ADC panel on standards for protocols to do this kind of thing. And anybody who's interested in that, I absolutely encourage you to get in touch with me. Come and mob me right away, because I want to start that conversation. Also, by the way, forgot to mention this URL here. I basically put together a set of support web pages for this talk. That's all you need. Get Dunne, that's my name, Dunne. getdunne.net/ADC2018. You'll find a summary of the whole talk, a bunch of topics I didn't get to today because they aren't that interesting, but it's all there, and I encourage you to please go and read that. Do we have any other questions?
More questions? You were asking earlier.
Are you aware that the VST3 specification is actually done with this in mind?
That's great. And as long as the APIs are open and as long as it can work, I'm not particular about saying we have to do it my way, but I'm here to start a conversation to say if there are things that might need to be added to it or things that might need to be changed in order to accommodate the kinds of plugins people want to make now and in the future, then I think we need to have this conversation going. I mean,
It's
as I said,
definitely
Apple had
worth
this
looking at it rather than reinventing the wheel completely.
Exactly.
Because no one has yet done something like this with the VST3 specification. So it would be great.
I'd be happy to have a look at it. You know, one of the things that makes this difficult is nobody pays me to do this. So I have to do it in the time that is left over after doing the things that people pay me to do. If anybody feels like paying me to do this, there's my address. Get in touch. You'll find me all ears.
Any more questions? One over there.
So think of the big studio using this one. You mentioned using this in a big studio with the server room. So imagine lots of VST or other plugins use this connection. Lots of data is transferred over this Ethernet connection. I think we need something like in the Ethernet networks, audio networks. So all the stuff related to bandwidth reservation and stuff like that. Is it already in there, or how do we get that? I think in a plugin it's not that easy to get into that area of network.
This is a really, really important question. If you do this on server hardware, we have a few advantages. One is servers typically have more than one Ethernet port. So it may be necessary in a heavily committed network situation like that you have multiple physical networks. But really what you're starting to touch on is another subject, which is, I haven't even gone into this yet, but I'm very, very interested in it, which is as soon as you start to have a heavily used heterogeneous system, you're going to need to figure out how are you going to do load balancing, basically. Because the last thing you want is, let's suppose you got a rack of 4 servers. One of them is being flogged to death, and the other 3 are just sitting there. You don't want that to happen. You don't want to put it into the lap of the users to say, well, you have to decide to choose your IP address so that it goes to this server and this port and so on. That's silly. You can't do that. So these things have to be also self-configuring and discoverable. These are the kind of things that have to go into the standardization, as well as making sure that we keep protocols extensible so that when somebody comes along and says, well, I need to drive my visualization, you need to still be able to do that. You don't want this to be something that just creates yet another set of limitations. Another one back there.
One at the back.
Along those same lines, have you looked at AVB or ASE67, I believe? It's the audio over Ethernet, because they've solved many of those problems already. If you haven't, you should check it out. There's an alliance called the Avenue Alliance.
Yeah, I'm interested in that stuff. I'd like to learn more about it. I'm not sure how well that would be extensible to support the kind of protocols that we need to send a mix of data back and forth.
Yeah, it deals with, I mean, I'm definitely not an expert on this. I've just read some, but it definitely provides quality of service controls and dedication of bandwidth, and it's also being built into, I mean, one of the challenges is I want to say this, as of a few years ago, many of the off-the-shelf routers and switches didn't have AVB built into them. That may be changing today.
Right.
But you have to get specialized equipment, and quite a few years ago, Apple was putting AVB into their network drivers, and so you're getting that built into the NICs on the devices. And I think the Waves, I think, is using it. A lot of companies are starting to pick this up. I believe Avid's using it for some of their products. So it's definitely something to look at for helping manage quality of service and all of those other things.
I think you're absolutely right. I mean, you want to find out what is happening in the field. I just want to come back to this slide with respect to that question because what I'm visualizing here, I didn't put a lot of text on the slides and so on, but what I'm visualizing here is a situation where there is MIDI and a mix of MIDI and audio going across the network on a regular sort of TCP/IP type of network here. Somewhere in the server room, you're computing a monitor mix. Now that is more likely to return to the control room or to the recording suite on one of these audio over Ethernet or IDAM or whatever it is, that is made to plug, basically to have a plug that plugs into the rest of the audio equipment as opposed to networking equipment. So yeah, I've kind of thought about it a little bit in that direction, but I would like to do more.
Any more questions? I have a question.
Yes.
You were sending a buffer at a time. Is that like a fixed size buffer?
All I'm doing right now is I just take the buffer size that's set in the DAW.
Okay. Okay.
I'm just proxying the.
It's just that you'll get different buffer sizes. I
Oh, absolutely. Yeah.
Okay. So you're just whatever comes in, you're chucking out. So it's kind of it's a FIFO, right?
Correct. Yeah.
Okay.
And you can change it during the session. It'll work. Yeah.
Very cool. Quick question in the front.
How large was the buffer which you were testing at?
Oh, I've tried buffer sizes up to, I tried them up to about 2K. But exactly, the important one is really not how large, but how small. And I found that in my implementations, things start to get a bit hairy once you get buffer sizes that are much below about 128. And I'm interested to dig into that and find out why is that? Where are the overheads? Where's the issue that is making that a problem? And how do we work around it?
Is this on?
Yeah.
It kind of feels to me like it would make sense to have a fixed size FIFO and then put that into your plug-in delay compensation number and then sort of ignore the buffer size. Have you tried that?
Because I have not. No, I've not done anything with...
To actually sync up the delay of losing a buffer and sending it and returning it, you kind of need to have your plugin reporting its delay.
Yes.
So the host can shuffle things around to compensate for that.
Yeah, that would require, though, that I've worked mostly with Logic Pro, and Logic Pro kind of says, okay, here's your size. Yeah. And so I don't actually know if I can do things like when you report your latency, if you can do it relative to the size you would ask for. Because then you're going to have to split the buffers, you're going to do various things.
You'd be better off picking a number.
Yeah.
And then ignoring and just dealing with whatever block sizes the DAW sends you. Because I've written a few DAWs and the block sizes are going to be all over the place.
This is really the kind of feedback that I want, is for somebody to come to me and say, here are the things that you haven't considered. Here's some relevant experience that means you should go in a certain direction. Are people generally interested in pursuing this as something that we try to talk about it may be too early to talk about standards, but to talk about what everybody wants, that maybe we need to put together some kind of a forum. I see one head nodding, that's good. I see more heads nodding now, that's good. In that case, then I've accomplished what I came here for, which is really just to start this conversation.
Okay, great. We're out of time, and there's a half-hour break now until 4 p.m. when the next session starts. So thanks very much once again to Shane.